Okay, in this example I'm going to show you a very simple type of transportation problem where you have costs associated with hiring drivers on certain routes, and you want to pick the combination of drivers and routes that will lead to the minimization of your total cost. In this case it's a bus routes for a school district, and you start off with you're given all of these costs associated with these routes. So you have route 1 and route 2, and you have driver 1, 2, and 3. They have submitted bids for driving these routes. So driver 1 says, I want $60 to drive route 1, and to drive route 2 I want $65. Driver 2 has said, I want $75 to drive route 1, and I want $70 to drive route 2, and driver 3 wants $80 to drive route 1 and $82 to drive route 2. Okay, so those are the bids. Those are the inputs to the model. Now, at the same time, we have to come up with what our decision variables are, and that will be whether or not a specific driver is assigned to a specific route. And if they are assigned, it'll be a 1 given, and if they're not assigned, it will be a 0. And I'm going to just put all zeros in here. The program is going to figure out what these 1s and 0s are in a minute. These are the decision variables right here. Okay, so there's no formulas associated with them. Also, ignore the colors that were up here. Those will change, and I'll explain that later. Okay, so our constraints are based on the sum of each row in each column. Essentially, each driver can only be assigned to one route. So that means you can't go like this. You can't put, I want to assign, driver 1 is cheaper at $60 and $65. So we're going to say, you can't say I want driver 1 to drive route 1 and route 2, because those routes run all at the same time. And so the driver can't be in two places at once. Okay, so that's the constraint right here. The sum of this row must be less than or equal to 1. It can be less than because you can decide not to assign a driver to a route because they're too expensive, for example. But if they are assigned, they can only be assigned to one of these routes, meaning the sum of this row must be less than or equal to 1. Okay, and that's true for every one of these. This row sum must be less than or equal to 1. This row sum must be less than or equal to 1. On the other hand, for routes, when you add up the assignments in each of these, in this column, all this must add up to 1. It has to add up to 1. You've got to have a driver for a route. So this is impossible for this linear program. You can't have, driver 1 assigned to route 1 and driver 2 assigned to route 1, because that would mean you'd have two buses running on the same route, and you don't need that. Okay, so it has to be only equal to 1 in this column. And this column's sum right here, this sum must also add up to 1 as well, equal 1. You've got to have a driver for route 2. Okay? Then the total cost is another sum product, where basically what we do is we take all this and multiply it by all this. So let me just put some numbers in here. Let's just say we assign driver 2 to route 1 and driver 3 to route 2. You see how that's going to be 1 times 75 times plus 1 times 82. 75 plus 82 is 157. Okay, so that's how that formula works. Now this is not the optimal solution, I know, because I did it before, but that's how the problem is structured. So now that we've got the formulas in here, let's run Solver to see what the optimal solution is. In fact, let's look at it intuitively. If you look for route 1, the driver that has the cheapest bid is driver 1. So we would assign driver 1, see the 1, I'm going to put a 1 there, to be the driver of route 1. And unfortunately, we can't use driver 1 again because a driver can only be assigned to one route. So now let's look here for route 2. We would like to assign driver 1 to route 2 because they only charge $65 and we're trying to minimize costs. But unfortunately, driver 1 is busy on route 1, so we have to exclude driver 1 from route 2. that leaves us with driver 2 and 3, and of those two, driver 2 is cheaper at $70. So what we would do, the solver model should put a 1 there. And that would mean that the minimum cost is equal to the $60 we have to pay driver 1 to run route 1, and the $70 we have to pay driver 2 to drive route 2. 60 plus 70 gives us 130, and that's the minimum solution, minimum cost solution. Okay, so let's get solver to do this for us now that we've structured this problem this way. What we would do is we would go to data and we would go to solver, and then what we do is we put the objective to being the total cost, and we would set it not to maximum but to minimum by changing all of these cells right here, subject to these constraints. And you can do it, you don't have to do these individually. You can say all that must be less than or equal to, which is the default, all that. Click on OK. And then we want to add one more constraint, and we want to say these two sums must be exactly equal to these right here. Click on OK. Okay, and we want to make sure that any unconstrained variables are non-negative, and we want to make sure we're using the simplex linear programming algorithm. We click on solve, and it found a solution. All constraints and optimality conditions are satisfied. So we click on this, and sure enough, it gave us the same solution that we were able to come up with intuitively earlier on. Driver 1 is assigned to route 1, and driver 2 is assigned to route 2, and driver 3 is not given any assignment whatsoever because they're too expensive. And the total cost is 60 plus 70, which is 130. So the question that you'll do might ask you this: route 1 is assigned to which driver? Well, you would look up here in your decision variables and you would say, well, driver 1 is assigned to route 1, and the cost is going to be $60. I'm just reading it from this column, column 1, route 1, the part in red, it's $60. That's what we chose for driver 1, route 1. The cheapest bid in this column was also $60, so I would put 60 there. The route 2, the driver assigned to route 2 was driver 2, and the cost, the cheapest cost in that column was $65. But unfortunately, we couldn't use that because that was driver 1, and driver 1 was already busy on route 1 for $60. So that means that the actual cost to the school district would be $70 for that one. And that's how you might summarize what some of these values are. Now, the last thing you have to worry about is the conditional formatting that's in here, and I'm just going to show you the formulas here. Basically, if it's red, that's what the actual cost is for you to hire a driver, that driver for that route. If it's green, that goes to show what a lower cost would be if you could had a different driver to go for that cost. And the way you would do that is you would go to Home, you would go to Conditional Formatting, Manage Rules, and you could see what these formulas are. Formula D12. So what you do here is you go D12. If it's equal to 1, then what that means is you've selected that driver for that route and highlight the corresponding position in this grid and highlight it in red. That's what that says. And apply that to this entire section right here, D5 to E7. That's what that says. Okay? Then the second formula for picking the lowest cost, if there is a lower cost, and you'll see there was no lower cost than 60 in column 1, so there's no green highlighting. But if there is a lower cost, then you want that to show in green in the route. And the formula used there was AND. AND says take these two conditions that we have here in parentheses, and if they're both true, then set the column that satisfies, or the cell that satisfies those two conditions, to green. And this is basically saying if the value in this part of the grid, and we just indicate the top left, and it seems to know to apply this to all of these cells here in relation to these cells on a one-to-one basis. But if this is 0, in this case, let's look here. If this is 0 and it's the smallest value in this column, it's the min of D5 to D7. And note where these dollar signs are. They're not at the beginning, they're just, this is a mixed address here. If it's, so basically what it's saying is if D5 is also the minimum value in here, then highlight it in green, just to show that there's an alternate lower value if you could get someone to work for that. Okay, so basically if D12, so what it's saying is if this value is 0 and it's the smallest value in the column, make it green. And the example I used was for here. This is 0 and 65 is the smallest in this column, so it's going to highlight it in green. And click on OK. And that's how the conditional formatting works. And that should give you an idea about how to solve this type of problem where you have bids and a cost associated with specific routes, and you want to pick the drivers with the lowest cost to provide you the minimum cost overall.